So this is a National 4, National 5 chemistry lesson. The subject is bonding, and today's lesson is about metallic bonding. So the aim of today's lesson is to be able to identify and describe metallic bonding. So in terms of our success criteria, we want you to be able to state the definition of metallic bonding, identify the types of molecules or compounds or elements that can make metallic bonds, and identify the properties of the different types of bonding. So metallic bonding. Metallic bonding only occurs between metal atoms. So this could be a pure metal like silver, gold, sodium, or it could be an alloy, and an alloy is a mixture of two elements together. So something like brass is a mixture of copper and zinc, and so that is an alloy, and it would also have metallic bonding. In this next box in the middle, we have the definition of metallic bonding, which you need to be able to say. So metallic bonding is the electrostatic force of attraction between positively charged ions and delocalized electrons. So metallic bonding is the electrostatic force of attraction between positively charged ions and delocalized electrons. Now, what we mean by delocalized electrons are electrons that are moving around the structure. Now, what happens in a metal is that, remember, metals want to give away electrons. And if there's nowhere for those electrons, if there's no non-metals for those electrons to go to, what happens is that those electrons that have been given up by the metals just move around between all these positive ions that have formed. So the metal atoms give up their electrons, they become positively charged ions. The electrons don't have anywhere to go, so they just are constantly moving between these different positive metal ions. And that's why we call them delocalized, because they've got nowhere to go and just keep moving around. So again, metallic bonding is the electrostatic attraction between delocalized electrons and the positively charged nuclei, or the positively charged ions. So this diagram just shows that the electrons are constantly moving, and the electrons between the metal ions are sometimes called as a delocalized cloud or a delocalized sea of electrons, because they're constantly moving, they're constantly flowing. Now, metallic bonding. All metallic compounds are able to conduct heat energy, and this is because of the bonding. The electrons are free to move, and so if you give electrons heat energy, they move faster and they move the heat energy with them. So that means that electrons, if you heat up one end of a metal, you heat up the electrons there, and they will move very quickly to the other end of the metal, and that causes the other end of the metal to start heating up. So that's why they can conduct heat easily. What about electricity? Well, if you are lucky, you would hopefully get to do this test, but you would be testing a few different compounds and seeing whether or not, if you attach a circuit around it, whether electricity can pass through the sample. And you might use a light bulb or a buzzer to indicate that the electricity is flowing. So what you would find is that metallic compounds can conduct electricity, covalent compounds cannot conduct electricity, with the exception of graphite, which can. And ionic compounds, when they are solids, they cannot conduct electricity, but when they are liquid or whenever they are dissolved in solution, they can. So how can ionic compounds conduct electricity? So as solids, ionic compounds cannot conduct electricity because their ions are bonded together in the lattice. And ions in a solid state cannot move. There are two conditions that are needed for a material to be able to conduct electricity. The first one is that the material must contain things that are charged. So that could be electrons and it could be ions. If you're just made of atoms that aren't charged, you cannot conduct electricity. You must have something that's charged inside your structure. And the second thing is that those charged things must be able to move. Covalent compounds don't have anything charged, so they cannot conduct electricity. Ionic compounds do have things that are charged. They are made of ions, so they're only made of things that are charged. But when they are a solid, these charges cannot move, and so it cannot conduct electricity. But when you dissolve it or you melt it, the charged particles, the ions, are now able to move, and so we've got charged particles, they can move, so it can conduct electricity. This is a good way to tell if a compound is ionic. It will only conduct electricity when it's dissolved or melted, but it will not conduct electricity when it's a solid. Now in a metal, anything that is delocalized can conduct electricity. Now ionic compounds, another property of ionic compounds is that they are usually soluble in water. This is because water molecules are slightly charged and so are able to attract the ions away from the lattice. And once they are free, the ions can move around and can start conducting electricity because they're delocalized. So hopefully you can now give the definition of metallic bonding, which is the electrostatic force of attraction between the positive metal ions and the delocalized electrons. You'll be able to identify that only metallic elements can make metallic bonds, and you should be able to identify the properties of different types of bonding. So this has been through the past few lessons and today. So with covalent compounds, covalent molecular compounds have low melting and boiling points and cannot conduct electricity. Covalent network compounds have high melting and boiling points and cannot conduct electricity. Ionic compounds have high melting and boiling points and cannot conduct electricity when they are solid, but can conduct electricity when they dissolve or melt. Metallic compounds have high melting and boiling points and can always conduct electricity. So now we have a few questions. So firstly, what is metallic bonding? Well, metallic bonding is the electrostatic force of attraction between delocalized electrons and the positively charged ions. So you could say nuclei, but it's better to say positively charged metal ions. What types of elements take part in metallic bonding? Metal elements only. So choose the correct answer. Metallic bonds are due to, for this one, it is D. Metallic bonds are due to the attraction of positively charged ions for delocalized electrons. And final question, metallic bonding is a force of attraction between A, positively charged ions and delocalized electrons. B doesn't describe any type of bonding because negative ions and delocalized electrons would repel one another. The type of bonding between negative ions and positive ions is ionic bonding. And the type of bonding that involves a shared pair of electrons and two nuclei is covalent bonding. So that concludes our set of lessons on bonding. You have looked at why atoms bond, and they bond to become more stable, and often they become more stable by obtaining a full outer shell of electrons. You've looked at covalent bonding, which is sharing of electrons that happens between non-metal atoms. And you've looked at the shapes of covalent molecules. You've been able to draw different types of diagrams, including electron cloud diagrams, to represent the shapes of molecules. We then looked at ionic compounds, and we learned that ionic compounds occur between metallic and non-metallic elements, and that you form ions first, and then the ionic bonding is the attraction that positive and negative ions have for one another. And finally, we finished by looking at metallic bonding, which can only happen in metallic elements and involves the bonding between delocalized electrons and positively charged ions. We also looked at how to compare the properties of all four types of bonding: covalent molecular, covalent network, ionic, and metallic. So that finishes our course on bonding. If you look at the main slide, there are lots more questions for you to practice on this, but this is the end of our narrated slides. So I will see you next time for a different topic entirely.